Now, if you go back to Faraday's law, we have seen that from Faraday, EMF is directly proportional to the rate of change of the total flux and phi with time. So if you remove the proportionality sign, you get a negative k dn phi dt. In that regard, the negative sign signifies Lenz's law. And therefore, if 1 volt is induced, and we have is the total voltage induced, and the total flux is 1 Weber in a time of 1 second, then the value of K is 1. If the value of K is 1, then we can be in position to induce the expression for EMF induced as being a negative dN phi dt, orange. And this is the mathematical expression which induces EMF in conductors or in bodies that are crossing a changing magnetic field. For example, it can be a changing magnetic flux, and there is a road cutting through. It can be an aeroplane. An aeroplane can be crossing the Earth's magnetic field. For example, you know the Earth is designed like this, with an imaginary polarity line. But if this is the Earth, and this is your North Pole, and this is your South Pole, there is a bar magnet inside the Earth with its polarity south in the north and north in the south. That's why when you freely suspend a bar magnet, it faces north-south direction, because the North Pole is trying to look for the South Pole of the magnet, of the Earth's magnet. So field will run from down this way, moving this way, like that. So if an aeroplane comes and cuts through this magnetic field, its wings can also induce an EMF. So planes can induce EMF as a result of crossing through the Earth's magnetic what? Field. So in that sense, we'll be changing the magnetic flux of the Earth. So whenever the flux changes, then the ends of the conductor can easily end up acquiring an EMF.